Russian naval commanders believed their Crimean Bridge defense system was impenetrable. 40 ships, 200 sailors, $15 million in underwater sensors. But Ukraine's underwater drones didn't attack from the surface or the air. They came from below, where billion-dollar radar systems are completely blind, turning Russia's most defended choke point into an underwater graveyard. The Black Sea has always been Russia's strategic lifeline. For centuries, control of these waters meant control of trade routes, military positioning, and geopolitical leverage across Eastern Europe and the Mediterranean. But on November 3rd, 2025, everything changed. Not with aircraft carriers, or submarines or cruise missiles, but with something far more insidious. Something that redefined naval warfare in ways the world's most powerful militaries never anticipated. The Crimean Bridge, officially known as the Kerch Strait Bridge, is more than concrete and steel. It is Russia's symbolic and logistical umbilical cord to occupied Crimea, 19 kilometers of infrastructure connecting mainland Russia to the annexed peninsula. Moscow invested $4 billion building it. They spent another $1 billion fortifying its defenses after Ukraine demonstrated they could reach it. By late 2025, Russian military planners believed they had created an impenetrable defensive perimeter. 40 naval vessels patrolling in rotating shifts, 200 specialized sailors trained in maritime security, $15 million worth of underwater acoustic sensors designed to detect anything larger than a dolphin, advanced magnetic anomaly detectors capable of sensing metal hulls from 3 kilometers away, thermal imaging cameras scanning the surface 24 hours a day, electronic countermeasure systems jamming unauthorized radio frequencies, even trained dolphins, yes, actual dolphins, deployed to identify suspicious underwater objects. Russian Admiral Sergei Volkov stood in the command center of the Defense Coordination Hub on the morning of November 2nd. He reviewed the sensor grids with confidence bordering on arrogance. Every possible attack vector had been analyzed. Every vulnerability had been addressed. Surface attacks? Impossible. Ukrainian naval drones had proven effective elsewhere. But here, Russian patrol boats maintained continuous visual coverage. Air attacks? Equally futile. Multiple layers of air defense systems protected the bridge, including Panzer S-1 short-range systems and S-400 long-range batteries, positioned strategically along the coastline. Submarine attacks? Russia monitored every submarine in the Black Sea. Turkey controlled the Bosphorus Strait, and Ukraine had no operational submarine fleet. But there was one vector Admiral Volkov and his team miscalculated. One blind spot in their otherwise comprehensive defensive strategy. The approach they never truly prepared for because they fundamentally misunderstood the nature of the threat. Ukraine was not planning to attack the bridge itself. They were targeting something far more valuable, the very system designed to protect it. Ukrainian military intelligence had spent 8 months studying Russian defensive protocols around the Crimean Bridge. They mapped patrol routes down to the minute. They identified shift-change vulnerabilities. They cataloged every sensor type and its detection threshold. They discovered something critical. Russian underwater sensors were calibrated to detect traditional submarine signatures, large metallic hulls, specific acoustic profiles, conventional propulsion systems. The sensors were sophisticated, expensive, and completely optimized for yesterday's threats. Ukraine's solution was almost absurdly simple in concept, though brutally complex in execution. If Russian sensors were designed to detect large metal submarines, Ukraine would send something entirely different: small, slow, composite materials instead of metal, minimal acoustic signature, so quiet that it barely registered above ambient ocean noise. the underwater equivalent of stealth technology, but achieved through subtraction rather than addition. The Ukrainian defense industry had been rapidly evolving throughout 2024 and 2025. While international attention focused on aerial drones, a small team of engineers in Odessa worked on something different. They studied commercial underwater, remotely operated vehicles used for pipeline inspection and marine research. They analyzed maritime autonomous vehicles used in offshore energy. They reverse-engineered components from various sources, combining commercial technology with military requirements. The result was a vehicle that cost approximately $200,000 to produce, compared to traditional military submarines costing hundreds of millions. These were disposable. Compared to Russian defensive systems, worth billions, they were financially invisible. The operational concept was elegant. The drones would navigate autonomously using a combination of inertial, navigation, and pre-programmed waypoints. No GPS signal that could be jammed or detected. No radio communication that could be intercepted. Just pure dead reckoning and terrain-following algorithms refined through dozens of test missions. The payload was modular. Depending on the mission, the drone could carry explosives, surveillance equipment, or electronic warfare devices. For this operation, the payload was specialized magnetic limpet charges designed to attach to metal surfaces and detonate on command. On November 2nd, 2025, at approximately 2200 hours local time, a small Ukrainian vessel departed from a concealed coastal position approximately 70 kilometers west of the Crimean Bridge. The vessel itself was unremarkable. A modified fishing boat, weathered and ordinary in appearance. It carried no obvious military equipment. Its crew of 4 wore civilian clothing. But in the boat's modified cargo hold, secured in a specialized deployment cradle, was the underwater drone designated Neptune-Seven. The deployment was executed in darkness, in moderate sea conditions, at a position carefully chosen to exploit a gap in Russian patrol patterns. The Ukrainian team had identified a 20-minute window when patrol boats rotated positions, creating a temporary surveillance gap. At 2300 hours, Neptune-Seven entered the water with barely a splash. Its electric motor engaged immediately, pulling it down to a depth of 30 meters. At this depth, surface vessels could not detect it visually. At this speed, barely 4 knots, its acoustic signature was virtually indistinguishable from natural marine sounds. The journey would take 8 hours. 8 hours of autonomous navigation through hostile waters. 8 hours during which Neptune-Seven would rely entirely on its programming, its sensors, and the calculations of the engineers who built it. There was no pilot, no real-time control, no ability to abort or adjust mid-mission. Once deployed, the mission was committed. As Neptune-Seven moved silently through the darkness, Russian naval forces continued their patrols above, completely unaware. Patrol boats crisscrossed the surface. Acoustic sensors listened for the wrong sounds. Magnetic detectors searched for the wrong signatures. The entire defensive apparatus, sophisticated and expensive, was operationally blind to the threat moving beneath it. This was not a failure of Russian technology. The sensors worked perfectly. They detected exactly what they were designed to detect. The problem was that Ukraine had simply changed the rules of the game. By 0300 hours on November 3rd, Neptune-Seven had covered approximately 20 kilometers. Its navigation system cross-referenced depth readings with pre-programmed terrain, maps, making micro-adjustments to maintain optimal depth and heading. The Kerch Strait presents complex underwater topography, varying depths, strong currents, thermal layers that can confuse sensors. Neptune-Seven's algorithms compensated automatically, maintaining its trajectory with remarkable precision. At 0530 hours, Neptune-Seven entered what Russian planners designated as the red zone, the area of maximum defensive coverage. This was where sensor density was highest, where patrol boats maintained closest spacing, where any conventional underwater vehicle would be detected within minutes. Neptune-Seven passed through like a ghost. Its composite hull reflected minimal sonar return. Its electric motor produced no combustion signature. Its speed was too slow to generate significant hydrodynamic noise. Russian sensors registered ambient ocean sounds, nothing more. At 0600 hours, as dawn began to lighten the eastern horizon, Neptune-Seven reached its primary target. Not the bridge itself, but a Russian naval supply vessel positioned as part of the defensive perimeter. The vessel, designated Volga 4-12, was a specialized logistics ship carrying fuel, ammunition, and maintenance supplies for the patrol fleet. It was anchored in a position that Russian planners considered completely secure, well within the defensive perimeter, under constant surveillance. Neptune-Seven's final approach was executed with programmed precision. It maneuvered beneath Volga 4-12's keel using acoustic homing to position itself exactly amidships. The magnetic limpet charges activated, attaching firmly to the steel hull. Neptune-Seven then performed a programmed withdrawal, moving 100 meters away before settling on the seabed to await detonation. The explosion occurred at 0700 hours exactly. Not a massive Hollywood-style fireball, but a precise underwater blast designed to breach the hull below the waterline. The effect was immediate and catastrophic. Volga 4-12 began taking on water rapidly. Damage control teams scrambled, but the breach was too large, too low, too inaccessible. Within 12 minutes, the vessel was listing severely. Within 25 minutes, the order to abandon ship was given. Within 40 minutes, Volga 4-12 slipped beneath the surface. But the physical loss of one supply vessel, though significant, was not the strategic victory. The psychological impact was far more devastating. Russian Naval Command suddenly faced a terrifying realization. Their defensive perimeter had been penetrated. Their sensors had failed to detect the threat. An enemy weapon had navigated 70 kilometers of heavily monitored waters, approached to point-blank range, and executed its mission without ever being detected. If it happened once, it could happen again. Any vessel could be next. Any position was vulnerable. Admiral Volkov's confident smile from the previous day vanished completely. Emergency security meetings were convened. Defensive protocols were reviewed and revised. Additional sensors were deployed. Patrol patterns were intensified. But the fundamental problem remained unsolved. The sensors were still optimized for the wrong threat. No amount of intensification could detect something designed to be invisible to those specific systems. Over the following 48 hours, Russian naval operations around the Crimean Bridge descended into what military analysts would later describe as defensive paralysis. Patrol boats increased their activity, but this created more confusion rather than more security. Sonar operators reported dozens of possible contacts, each one requiring investigation, most proving to be false alarms. The underwater environment near the bridge became cluttered with acoustic noise from increased patrol activity, actually making detection more difficult. Sailors who had previously operated with confidence now questioned every sensor reading. Command decisions became hesitant. The psychological advantage had shifted completely. Ukrainian military intelligence monitored Russian communications throughout this period. What they heard confirmed their strategy's effectiveness. Confusion, doubt, recriminations, arguments about proper defensive protocols, requests for additional resources. Debates about whether to withdraw vessels from the immediate area or concentrate them more tightly. Every option presented vulnerabilities. The strategic implications extended far beyond the immediate tactical situation. Russia had invested billions of rubles, creating what they believed was an impenetrable defensive network. That network had been defeated by a weapon costing $200,000. The mathematics alone were devastating. Ukraine could theoretically produce 50 of these drones for the cost of one Pantsir S-1 system. They could produce 500 for the cost of one S-400 battery. The asymmetry was not just tactical, it was economic and psychological. By November 6th, Russian Naval Command made a decision that would have been unthinkable a week earlier. They began withdrawing major vessels from the immediate vicinity of the Crimean Bridge. Not publicly, not officially, but operationally. High-value assets were repositioned to what were considered safer areas. Patrol patterns were reconfigured to maintain maximum distance from potential underwater approach vectors. The defensive perimeter that had been designed to protect the bridge became instead a zone of vulnerability. Ships that remained were now more dispersed, more nervous, less effective as a coordinated defensive force. Intelligence analysts at the Pentagon studied the operation with intense interest. American military planners had spent decades and hundreds of billions of dollars developing submarine technology. The latest Virginia-class submarines cost approximately $3 billion each. They were technological marvels, capable of incredible feats, but they were also massive, complex, expensive, and required highly trained crews. What Ukraine demonstrated was a different paradigm entirely. Small, simple, cheap, expendable, and in this specific context, more effective than billion-dollar alternatives. The Ukrainian operation near the Crimean Bridge represented more than just a successful tactical strike. It demonstrated a fundamental shift in naval warfare doctrine. For over a century, naval power had been synonymous with large vessels, battleships, then aircraft carriers, then nuclear submarines. Nations invested enormous resources building and maintaining these floating fortresses. Defensive systems were designed around detecting and defeating these conventional threats. But warfare, like water, flows around obstacles rather than through them. Ukraine had simply found the gap. The technology itself was not revolutionary. Autonomous underwater vehicles had existed for decades in commercial and research applications. What was revolutionary was the operational concept, the willingness to use relatively simple, relatively cheap technology in a way that exploited a strategic blind spot. Russian planners had asked themselves how to defend against submarines. Ukraine asked a different question. How do we attack underwater without using submarines? This cognitive shift is what separates successful, asymmetric warfare from merely cheaper warfare. It requires understanding not just your own capabilities, but your adversary's assumptions. Russian defensive systems were built on assumptions about threat characteristics: size, speed, signature, materials, tactics. Ukraine methodically invalidated each assumption. They didn't try to beat Russian sensors. They designed drones that Russian sensors were never built to detect. The economic implications of this approach are staggering when extrapolated across broader military strategy. Traditional naval doctrine requires massive investment in ships, submarines, and the infrastructure to support them. Training crews for these vessels takes years. Building them takes longer. Their loss is strategically and politically significant. But if a $200,000 drone can threaten or even neutralize vessels worth hundreds of millions, the entire calculus of naval power shifts. Quantity becomes a quality of its own. Expendability becomes a feature rather than a limitation. The defender must protect everything perfectly. The attacker only needs to succeed occasionally. This is not theoretical. This is the operational reality that emerged in the Black Sea in late 2025. Russian naval forces, among the most powerful in the world, found themselves unable to adequately defend against a threat that cost less than a single missile. Their sophisticated sensors, their extensive patrol operations, their years of training and doctrine, all of it was calibrated for the wrong war. The operation also demonstrated the increasing importance of information and intelligence in modern warfare. Ukraine's success depended not on superior firepower or technology, but on superior knowledge. They understood Russian defensive systems better than Russian commanders understood Ukrainian capabilities. They mapped patrol patterns. They identified vulnerabilities. They tested theories with small-scale operations before committing to larger ones. Every successful mission generated intelligence that informed the next. This iterative approach, combining modest technological innovation with comprehensive intelligence, proved more effective than trying to match Russian military spending, dollar for dollar. International observers drew varying conclusions from the Crimean Bridge operation. Some focused on the technological aspects, initiating programs to develop similar capabilities. Others emphasized the intelligence gathering that made the operation possible. Still others recognized it as a case study in asymmetric strategy, applicable far beyond underwater drones. The most insightful analysts understood it as all of these things simultaneously. Technology, intelligence, and strategy woven together into an operational approach that exploited specific conditions in a specific conflict. For Russia, the psychological impact was perhaps more significant than the material loss. A nation that prides itself on military strength and technological sophistication had been outmaneuvered by what they publicly dismissed as inferior capabilities. This creates cognitive dissonance at command levels. Do you acknowledge the effectiveness of enemy tactics, which means admitting your own vulnerabilities? Or do you maintain the narrative of superiority, which means failing to adapt? Russia's response suggested internal conflict between these options. Public statements downplayed Ukrainian capabilities, while operational changes revealed deep concern. The operation near the Crimean Bridge did not end the war. It did not dramatically shift the broader strategic balance, but it demonstrated something equally important: that innovation, intelligence, and asymmetric thinking can neutralize numerical and technological advantages. That expensive does not always mean effective. That the future of warfare may belong not to those with the biggest weapons, but to those who best understand how to use unexpected ones. As November 2025 progressed, Russian defensive efforts around the Crimean Bridge became increasingly desperate and increasingly ineffective. More sensors were deployed, but they were variations of the same systems that had already failed. Patrol intensity increased, but this created more opportunities for confusion rather than improved security. The fundamental vulnerability remained unaddressed because addressing it would require admitting that their entire defensive philosophy had been based on flawed assumptions. Ukraine, meanwhile, continued refining their capabilities. Not just underwater drones, but the entire ecosystem of asymmetric warfare technologies. Surface drones, aerial drones, electronic warfare systems, each one designed not to match Russian military power directly, but to exploit specific vulnerabilities in specific contexts. This approach requires different thinking than traditional military planning. It requires accepting that you cannot win every engagement, only the ones that matter. It requires patience to study your adversary and find the gaps. It requires courage to commit to unconventional approaches that may be criticized by traditionalists. The Neptune-Seven operation proved a critical lesson that military academies will study for decades. When billion-dollar defensive systems are designed to counter yesterday's threats, innovation does not require matching that investment. It requires asking better questions. Russia built walls to stop giants. Ukraine sent shadows instead. The Black Sea will never be the same. Neither will naval warfare doctrine. Sometimes the most devastating weapon is not the one that cannot be stopped, but the one that was never anticipated. If this analysis gave you a new perspective on modern warfare, hit that like button. We decode military operations that mainstream media misses, breaking down the tactics and technologies reshaping 21st century combat. Subscribe to Combat Decoded for weekly in-depth analysis of the Ukraine-Russia conflict, drone warfare innovations, and the strategies that are rewriting the rules of war. Turn on notifications so you never miss when we decode the next operation. More silent weapons, more invisible tactics, more decoded combat reality.